So before we dive into the crux of the video, the heart of the video, I want to tell you a problem statement. And from this problem statement, we can analyze why vector databases are actually needed, and not just in RAG. Let me tell you, not just in AI. Vector databases are used in wide way. We will see how this is interlinked to the need of vector databases. Okay, so imagine that you are working in a company, and that company has assigned you a task that your problem statement or the task that they have assigned you is to create a AI application where anyone can come in within the organization. It can be the CEO of the company, it can be the HR, or it can be just an intern, right? They can come in and they should be in a place that they can come in the chatbot and ask the query, and the query should give the answer, and this answer should be limited to the organization only. Okay, it should not work outside of the company. And if you ask the same question to chat gpt about the, like, let's say I'm working in kpmg, right? If I work in kpmg, then the question which I'm asking to chat gpt related to the internal working of kpmg, it might not know the answer, but our chat application should know the answer. So now my question is, let's focus on the database. What database should we use? Should we use the regular databases like MongoDB or SQL, MySQL? Like, should we use that? Right? For this problem statement, is this the correct database? Let's imagine a scenario, a case, right? Imagine that I'm asking in the chat application, I'm asking, like, tell me the vacations that I have, right? So when I type how many vacations I have in 2026, what we will do is that internally our application will go to the database. It will search the exact keyword, right? It will search vacations, and whatever the vacations data I have, I'll just give that to the user. Okay, understood. So here what we are doing is that we are searching based on the exact match of the word. Now, I might ask the same question in the by using other words. For example, I'm asking, like, how many days are off? How many vacations are there, and how many off days are there? Both are same. The meaning of the question, like, the meaning is same, but the words which I have used is widely different. And if we are looking for the exact keyword match, then in the question which I have given, how many days are off, there is no exact match, then I'll get most probably the wrong answer. So here, the regular databases, MySQL or non-relational database like MongoDB, fails here because this databases are built to find the exact keyword, exact match. Now, when it comes to vector databases, here we this vector databases are really important and useful in this case, because in vector databases what we do is we search for similarity search, we search for intent, semantic, how many days are off, the semantic meaning, we're extracting the semantic meaning first, then we take this meaning, go and search in our vector databases, then we'll get the accurate answer. So this is the main difference. In regular databases we use regular word search, but when it comes to vector databases we use semantic search, we use intent based searching. Database we store data in the form of rows and columns. In non-relational database, we store the data in the form of documents, key value pairs. Similarly, when it comes to a vector database, we store the data in the form of embeddings, in the form of vectors, right? Like, this is not a mathematical class, so I'll not go into the depths of it, but just understand that we store the data in the form of vectors. And what are vectors? Vectors are nothing but a single dimensional array, and in the given array we store the similar words in the form of numbers. Okay, now I hope you have understood that what is the need of vector data. We need to create a AI application which will act as the brain of the entire organization. So what we will do is that we take the document, we classify the document based on the meanings. This is known as intent classification. Okay, after doing intent classification, we segregate documents in different categories. For example, a set of category of documents can be related to HR department, and another set can be executive department or executive related documents. Similarly, another set of documents can be development related documents. We segregate the documents first. After segregating the documents, what we will do is that we start creating chunks, and each chunk will have 300 to 400 tokens. Tokens are nothing but words. We take 300 to 400 words, create a chunk, and we will have overlap around 100 words. Then another chunk like this. We create different chunks, and we convert these chunks into vectors. Imagine vectors as a single dimensional array, and in this array we are storing numbers, right? For example, let's say in development there's React, Python, .NET, all these different things, right? So whenever a technical terminology comes in, we store that document in the collection of development, and all the development related words will be stored near to one another, and the number will be near to one another. Now when a question, first thing is completed. Now in the second thing, what we will do is that whenever a query comes in, we convert that query into numbers, and we take these numbers, go to the vector database, search the similar numbers, the numbers which are very near to the query, search them, extract them, and what we will do in RAG specifically is that we take the query, we take the retrieved documents, and we give the instructions, right? How the answer should be, in what format, what we should not do, what the LLM should do, everything. We give all the instructions. By combining this three, we call this three as system prompt, right? We give the system prompt to the LLM, then LLM will understand the entire context, and based on the context, it will give the answer. This is how we use vector databases in RAG application. If I have to draw parallels to real world, imagine that a student is writing exam, and he has learned few things, and from whatever the things he has learned, he is writing the answer. Okay, so this is what a normal LLM will do. If you ask a query, it will go to the database from which it has learned and write the answer accordingly. Now imagine that a LLM, or this in our case a child, does not know the answer because he hadn't studied it, he hadn't learned it, then he will not write it. Similarly, if you ask a LLM a question which is not related to the data set on which it has been trained upon, then it will give you the answer like, I don't know. I don't know because I haven't trained on that thing. Now imagine that in this exam, the student is writing, I have provided a textbook, and if the student don't know the answer, then he has the opportunity, he has the freedom to go onto the textbook and search, right? He can go and search whatever the answer he wants based on the question, and after searching, he's writing the answer. This is what happens in RAG, right? What LLM will do is that LLM will go back to the textbook, and the textbook here is vector database, our knowledge base, right? And he will search the knowledge base, and he will retrieve the similar documents, understand the documents, and then answer the question. This is what we do in RAG. There are different databases. For example, if you take non-relational database, we have MongoDB, GraphQL, Redis, like this we have a number, right? Similarly, we have different types of vector databases like Chroma DB. Chroma DB is perfect if you want to run everything locally, right? That is the most perfect DB vector database we have. And if you want speed, if you want most powerful, like let's say you want to build the enterprise level application, then Quadrant vector database is for you. And Quadrant database is my personal favorite one for whatever the applications I have built in RAG, right? It can be tax related applications, AI applications, or like company specific applications which I have built, right? For all applications, I have most of the times used Quadrant because I like Quadrant. I am used to of vector databases. For example, if you take Pinterest, right? Let's say you like some sort of images which has a particular aesthetics. Then what will happen is that internally they run their image classification models. They extract the like exact pixels. Pixels are nothing but a three-dimensional array, right? They extract the exact pixels which you are liking, and based on the exact like sort of images, sort of set of pixels of images which you are liking, they will go in their vector database, in their knowledge base. They'll retrieve the similar documents which has the exact replica of the pixels, exact pixels which are near to this particular image. They'll show you the same images. Similar thing goes with Netflix, right? Similar thing goes with like Spotify is the best example which I can give, right? Whenever you're like, let's say you're listening, you're liking pop music, right? A music which has this particular bass or this particular lyrics, then what they'll do is that internally they have the audio in the form of numbers, and let's say these numbers are 100, 200, and 300. Now what they'll do is that they'll go to the knowledge base. In this case they use vector database. They go to their personal knowledge base, Spotify knowledge base, and they'll search the numbers which are near to the numbers which you have listened. Okay, and whatever the numbers which are near, numbers are here songs, they'll retrieve the same things and give it to you. This is what happens. So and understood how everything works. So with that being said, I'll stop here. I don't want to talk much. So if you watched till here, thank you for watching. It really means to me a lot.